Hey guys, welcome back to my channel, The Math Lab. And today we're going to do indices. So for indices, we first need to be familiar with laws of indices. So first law says when we're multiplying same bases, when I say the term base, basically A is the base and M represents the power, N represents the power. So I'm just going to highlight this. This is the power index, whatever you want to call it. When you're multiplying bases, similar bases, what we're going to do is we're going to add the powers. If we're going to divide similar bases, we're going to subtract the powers. If we have a power inside the brackets and then there's a power outside the brackets, what we do is we multiply the powers. Then if we have a base which is written as a fraction, so if we have a fractional base, let's say we have 1 over a to the power of m. So 1 over a to the power of m can be rewritten as a to the power of negative m. So this way you can convert negative indices into positive indices by converting into a fraction. Or if, for example, the fractional indices is with the negative powers, for example, if it's 1 over a to the power of negative m, this can be rewritten as a to the power of m. So basically, when you move the base, like switch the place of the base from the numerator to the denominator or from the denominator to the numerator, the sign of the power changes. Then apart from this, anything to the power of 0 will always equal to 1. We have the product law, the division law, and yeah, basically these are the laws of indices which you need to be familiar with in solving questions. So if we move to the questions now, first question says 2 to the power of negative 4 times 2 to the power of 5. So as you can see, same base over here, which is 2. So when you have similar bases being multiplied, we add the powers. So what we're going to do is we're going to add negative 4 to 5, and that gives us 2 to the power of 1, which can be rewritten as just 2. Then if we look at the second question, it's applying the product rule. So there's a power inside the bracket, and now there's a power outside the bracket, which means we will multiply the powers. So it becomes m to the power of 10. Now in this case, we have several terms being multiplied. So what I would suggest is let's split each term. So write it as 4 times x cubed times y, then times 5 times x squared times y. Once we've split all of the terms into its components, what I'm going to do is I'm going to rearrange this, and I'm just going to write the constants together. By constants, I mean the numbers together, the x variables together, and the y variables together. So what we're going to do is we're going to do 4 times 5 times x cubed times x squared times y times y. 4 times 5 we know is 20. Now if I highlight the x cubed times x squared part, we can easily see that we're multiplying two similar bases. And when we're multiplying two similar bases, we add the powers. Same case over here. We're multiplying two similar bases. which means we will add the powers. So 2 times x to the power of 5 times y squared. So the final answer would be 20 x to the power of 5 y squared. Similarly, if you look at question number 4, it says 6 times w to the power of 0. Now we just learned that anything raised to the power of 0 equals to 1. Hence, if we split this into 6 times w to the power of 0, w to the power of 0 can be rewritten as 1. So the answer is 6. When we talk about adding or subtracting variables, we need to make sure that in order for us to combine the variables, like by combine, I mean whether we're adding them or subtracting them, we need to see that the variables being added or subtracted are the same and they are raised to the same power. In this case, since x is present with both 5 and 3, it checks the first condition that the variables are same. Second condition being that the powers need to be same as well. So as we can see, x is raised to the power of 3 and x is raised to the power of 3 in both cases. Hence, we can easily subtract 3x cubed from 5x cubed, which gives us 2x cubed. In the next question, we're multiplying 3 times y to the power of 6 with 5 times y to the power of negative 2. So what we can do is, there are two ways of solving this. Either we can do it through the first way, where we split the terms into its components, rearrange the terms and write the numbers together and the similar variables together. We know 3 times 5 is 15. And for y times y to the power of 6 times y to the power of negative 2, similar bases are being multiplied again, so we will add the powers. So when we add the powers, we're getting 15 times y to the power of 4. Alternate method could have been as that we, in the first step, actually change the negative power to a positive one. So as we did earlier, if like the power is negative and if it's in the numerator, we can bring in the denominator and the power becomes positive. So keeping that in mind, I will only move y in the denominator, not 5. 5 remains as it is. So it becomes 5 times 1 over y squared now. So it's basically 3y to the power of 6 times 5 over y squared. 3 times 5 is 15. And for the y's, what we can do is we can apply the division rule, where when a similar bases are being divided, you will subtract the powers. So which is 15 times y to the power of. Then if we look at question 5, it says write 5 to the power of negative 3 as a fraction. Same thing. We write 5 to the power of negative 3 as 1 over 5 to the power of negative 3. And then we just convert 5 to the power of 3 into whole numbers, which would give us 125. So 1 over 125 is your answer as a fraction. Then let's see, question number 7. If you look at question 7, it says simplify 16p to the power of 16 whole power 1 over 4. So in this case, in the previous cases, what we had was there was only a variable inside the bracket. There wasn't a coefficient inside the bracket. In this case, there's a coefficient. 16 is your coefficient. P is your variable. So what I'm going to do is, when I'm going to just open the brackets and multiply the power that is outside the bracket, what I'm going to do is I'm going to distribute it with both the terms. So it's going to be 16 to the power of 104 times p to the power of 16 times 104. The 104 went with 16 and the 104 went with the p as well. The thing is, with 16, every whole number has a power of 1. So 1 times 104 is just 104. That's why I wrote 104 as it is. But in the other case, since there's the power of 16 with p, so the 104 gets multiplied to 16 in this case. So 16 raised to the power 104 is basically 2. How did I get that? The thing is, 4 square is 16. And we know 4 is 2 square. So if we rewrite 4 square, we can write it as 2 square whole power 2, which is basically 2 to the power of 4. So 16 can be replaced with 2 to the power of 4, and the 104 comes outside as it is. 16 times 104 is 4. Then we do 4 times 104, which is 1. So it's 2p to the power of 4. Now these questions mostly come in cases where you're not supposed to use the calculator. So for that, you need to be familiar with, perfect square terms, cube terms, so that you can easily solve them mentally. Then similarly in part B over here, we have 3p square m to the power of 5 inside the brackets, and outside the brackets is the power of 3. We're going to do the same thing. We're going to apply the same rule over here. The power of 3 is going to get distributed with all three terms. So it's going to be 3 to the power of 3 times p square to the power of 3 times m to the power of 5, then again power of 3. 3 cubed, 27. 2 times 3, 6. 5 times 3, 15. So 27, p to the power of 6, m to the power of 15. Question number 9. So if you look at this, now there's like a fraction where we have terms in the numerator and denominator, and the variables are raised to different powers. And then there's brackets, and then there's power outside the bracket as well. So first thing what we're going to do is we're going to distribute the power with the numerator and the denominator. So I'm going to write it like this: x to the power of 64, then whole power of 104, divided by 16y to the power of 16 and whole power of 104. Next, what we're going to do is we're going to multiply 64 with 104. So 64 times 104. And over in the denominator, we're going to distribute the power with 16, power of 104, and y to the power of 16 times 104. This is similar to the previous question. 64 divided by 4 would give us 16. And this would be once again 2 to the power of 4, whole power of 104 times y to the power of 4, x to the power of 16 over 2 y to the power of 4. That is your answer. So if you still have any confusions or questions about this topic, just let me know in the comments below and I hope you have.